Surely I can just do any.
process. So, geometric series, a very basic one would be 1 plus 2 plus 4 plus 8 plus 16 plus 32. I'm going to call that the sum, like that. Okay. So it is a short one. We could just add it together, but obviously we want to know what happens if we've got more numbers. So I am going to write again. Remember we did the arithmetic one where we wrote the same one but backwards?
Yep.
Not going to do that. I'm going to do something similar, but I'm not going to do that. I'm going to do two lots of the sum. And the reason why I'm going to do two lots of the sum is because now the numbers become 2 plus 4 plus 8 plus 16 plus 32 plus 64. Okay, the way I've written it is a clue. I'm then going to do two lots of the sum minus one lot of the sum is going to be 64 minus 1, isn't it? Because it's going to be 2 minus 2, 4 minus 4, 8 minus, and then it's going to be 64 minus 0, or 0 minus 1, or just, we're basically going to be left with this one, and we're doing a subtraction.
Why is 2 times the sum written like that?
What do you mean 2 times?
2s. And
2 lots of the sum of s of n.
Oh, okay.
Yeah. 2 times it.
Okay.
What I'm going to do at this stage is I want to know what one lot of the sum is. Okay. Now you might go, well, actually, therefore, one lot of the sum is just 63. All right. However, what's happened there is not necessarily going to be possible when you do it algebraically. However, that's the kind of approach. The first bit, at least, is what I do. So I've got one lot of the sum. I've multiplied, I'm going to say that very carefully. I've multiplied this one by a value. In this case, it's 2.
But it doesn't always have to be.
Up to you to make that decision. What would that value be for a different set of numbers, for instance? The point of doing it is so that I get this version. When I subtract, I can get rid of all these middle terms and I've got just the first term and the last term. Okay? So, have a think. How would it work? Well, it's up to you. You can think, how would it work if I did it with another one? So, instead of doing times 2, what would I do if I had one that was times 3? Or I'll let you think it through. You can discuss it with each other. What would it happen? If you want, you could go straight to the algebraic version, but I'm not going to tell you how I would do that. It's up to you. We'll come back to this in about 10 minutes' time and see what you come with. All right, that's all right. I'm not going to give any answers. So a little bit, guys. So for instance, I did one here that was a sequence that went up times by 2. So R was 2. But what if I did one, it starts at 2 and add on the next term, let's make R3 this time. So it would be 2 plus 6 plus 18 plus 54 plus 162. Let's stop there. All right. What would I do now to get a sequence that can be simplified in the way that I did? Would I multiply by 2? Because if I did, I would end up with 4 plus 12 plus 36. And there's nothing disappearing when I subtract. So that's not working for me. So what am I going to multiply by?
3.
So if I multiply by 3, I then get 2 times 3 is 6, and I can line it up, and then it's easy. So 18, 54, 162, and then I need a 300, 180, 480, 486. Yeah. All right, so what do I do at that point? Well, now I can do the thing I did do, which is 3 lots of Sn minus 1 lot will give me 486 minus 2. Okay, 2Sn equals 484, so then Sn is 484 over 2, which is 242. Okay, so that's a numerical approach to doing it. So what we want to do is try and generalize that. Right. So has anyone had a go? Okay. So I guess let's identify a couple of things. For instance, what am I multiplying here by?
R.
So I could replace that with an R. All right. So instead of a 3, I would have an R. All right. Now that's going to cause you potential issues. It's very easy to overcome at this stage, because this would then be, well, I'm not going to tell you because I want you to go through it. 2 is obviously A. Okay. You've been going for the final term is UN.
Yeah.
But actually, what we should probably do is treat it like A times R to the power of
Something minus 1.
N minus 1.
Yeah.
All right?
Yeah.
Hopefully that will guide you as to what matters. So this is what matters here. We've got that one. But we want this one. So we know this is A. What is this one? Again, don't tell me an answer. I'm not going to tell you. That's for you to sort out. And then you think, well, what am I going to do once I've got all the letters in place rather than numbers? That's kind of what you're looking for. All right, so I'll give you a few more moments to try and figure that out.
So
Tell me, but so this term here, this number is not a term in this series. All right, but we need it to work out the sum. That's what we've done here, yeah? So this, people have been calling UN. This is not UN. All right? It's actually UN plus 1. It's 1 further. This is my UN. This is the final term. So this N relates this N, the final term. So we've got to be a little bit careful. But anyway, I don't want to use this notation. I want to use the stuff we can use for the formula. So what do we do? Well, the sum of a sequence, or a series, sorry. So we're going to start with A plus, what's the next term called? A times plus AR squared plus AR cubed, so on, up to AR N minus 1 is the final term. All right? Make sense?
Yeah.
Okay. If I take the second row, which I've been doing, hopefully what you've now done is said, it's not 2 lots always, or 3 lots, it's R times Sn. So what does that do for me? Well, it takes A and multiplies it by R. So we've got AR again, and then we've got AR times R is AR squared, and then we've got AR cubed. We've got AR to the N minus 1, but we've got another term now, this new term, which is
AR
this
to
times
N
R,
minus
which is just AR to the power of N.
Oh, because it's plus.
Just add 1 to the exponent, right? Okay. What do we then do? Well, we were subtracting. Oh, that's not what I wanted to do. We were subtracting those, and we were left with this one and this one. So that would give me RSN minus SN equals AR to the N minus A. Okay. We want Sn on its own. Now, this is where the difficulty in have to use algebra. I can't subtract. So here I could do 2 subtract 1 or 3 subtract 1 or whatever. But in this case, I need to get S on its own. And hopefully you remember from your IGCSE days, the best way to do that is to factorize. So when we factorize Sn out, we get r minus 1. And on this side, I can simplify by factorizing as well. I'm going to go a times Rn minus 1. Okay. Now to get Sn, all I need to do is divide through. So I've got a times Rn minus 1 over r minus 1. It's even on the video. So that's YouTube music. So that's your.
Copyrighted.
Do you know it happened to me once? I had.
But you don't make any money off of your video.
No. There was another version which is Sn is a 1 minus r to the n over 1 minus r. Now that makes perfect sense because if this is a positive, this will be a positive. If this is negative, this is a negative. Negative divided by negative is still going to be positive. How would I have done this but ended up with this instead of this? Well, I subtracted this way around. What if I subtracted the other way around? What if I'd have done Sn minus Rsn is equal to a minus r Arn? I'd have just ended up with this one, wouldn't I?
Yeah.
Exactly the same thing. Which is why the book is wrong, because the thing to remember is it doesn't matter which way round it is as long as they're both the same. So if I turned this one r minus 1 but didn't do it to the top, I would then impact. It would always be a negative when it shouldn't be, or a positive when it shouldn't be, or whatever. Okay. So there is your formula for the sum of a
It's
geometric
equivalent,
series.
but it's not. Yeah, it is equivalent, but it's just a
Yeah.
bit more complicated.
So this is the one you'll see in your formula booklet. Obviously, how would I use this to figure out how many terms if I'm told the sum of the series is this? I'd be finding an unknown exponent. How do you do that? Logarithms again. Yeah? So we can use this formula, but now you know where it's come from, hopefully you're good to